Okay, get ready for this because what we're talking about today, it feels like it's straight out of a sci-fi movie, but it's real. We're not just talking about a robot that, looks kind of human. No, this is about a machine that is, in a very real sense, becoming part human.
So here's the big idea, the headline you need to know. Just forget everything you think you know about robot skin. Forget silicone, forget rubber, all that synthetic stuff. The breakthrough we're diving into today is a robot covered in actual, living, healing, human skin tissue. Yeah, you heard that right.
So, who's the genius behind this? Well, it's a team over at the University of Tokyo, led by Professor Shoji Takeuchi. What they've done is create a robotic face that can actually smile using this living skin. And the secret sauce? It's this brand new way they figured out to attach the living tissue to the machine. And let me tell you, this isn't just some small step forward. It's a massive leap, a totally new chapter for what we call biohybrid robots.
Okay, but you might be thinking, why? Why go through all this trouble to grow living skin for a robot? It sounds like a lot of work. And to really get that, we need to talk about this huge, nagging problem in robotics, something called the uncanny valley.
For years and years, the big goal was to make robots look more human, right? First, we had those hard plastic shells, think of something like Honda's Asimo. Then, in the 2010s, we got into softer materials like silicone. And then just a couple of years ago, in 2022, this same lab actually put living skin on a robotic finger. That was a huge first step, but there was a problem. The skin just peeled right off. It couldn't handle the movement. And that's why this new discovery is such a game changer. They finally cracked the code on how to make it stick.
And this really gets to the heart of the problem. That uncanny valley, you've probably felt it. It's that weird, kind of creepy feeling you get when you see a robot or a CGI character that looks almost perfectly human, but not quite. Something is just off. And for the longest time, synthetic robot skins have been stuck deep in that valley. They just don't look or move or feel right.
Just look at the difference side by side. Your typical silicone skin, if you cut it, that's it, it's done. But this living tissue, it can actually heal itself. Silicone feels cold, plasticky. This stuff has the natural pores and warmth of real skin. And this is the big one. When a robot with silicone moves, the skin can crack or tear. This new skin stretches, it contracts, it heals. It moves with the robot. The whole point is to finally climb out of that uncanny valley for good.
So, the billion-dollar question is, how? How on earth did they do it? How do you take living biological cells and fuse them onto a cold metal and plastic frame so that it can smile? Well, the answer is just brilliant, and it's all about looking to nature for inspiration.
The team literally looked at our own bodies. Think about it. Our skin isn't just sitting on top of us, it's anchored to the tissue underneath by these tiny things called ligaments. So they basically copied that idea. They designed the robot's face with these special V-shaped holes, or perforations, that act like thousands of tiny little anchors for the new skin to grow into and grab onto.
Okay, so here's the play-by-play. Step 1, they 3D print the robot's face, complete with all those V-shaped anchors. Step 2, they pour this special collagen gel mixed with human dermis cells, that's the deep layer of your skin, all over it. Now this is the cool part. Over about a week, those cells get to work. They naturally contract and tighten that gel, pulling it deep into the anchors and locking it in place. Then, for the final step, they add the top layer of skin cells, the epidermis, and let it grow. And boom, you have a complete 2-layer living skin.
And did it work? Oh yeah, it worked. The results were absolutely incredible. The data basically shows that without these anchors, the skin just slides right off, almost no grip at all. But with the anchors, the bond was over 17 times stronger. 17! That's the difference between skin that peels away the second the robot moves and skin that can actually handle the stretching and pulling of a genuine smile.
And you've got to understand, this isn't just about making robots prettier. It's not just cosmetic. As Professor Takeuchi himself says, the real motivation here is so much bigger. The dream is to create robots that can heal themselves, robots that can feel their environment in a more accurate way, and that can perform tasks with the same kind of dexterity that we have.
Okay, so we have this amazing technology, but what's it for? What are the real-world uses for a smiling robot with living skin? Well, the impact here is huge, and it pretty much splits down the middle into two big areas: robotics and medicine.
First up in robotics, this is all about how we interact with them. Just picture a companion robot for someone in elder care, but instead of a plastic face, it has a genuinely warm and empathetic one.
Or think about service robots in hotels or stores that don't give you that creepy vibe. And looking further down the road, this could lead to humanoids that can sweat to cool their systems or even have an integrated, realistic sense of touch. Wild stuff.
But honestly, the potential in medicine might be even bigger. We're talking about creating face-on-a-chip platforms to test things like cosmetics or drugs without ever needing to use an animal. Think about surgical training. Surgeons could practice on mannequins that have skin that actually bleeds and heals like a real person. And that anchoring technique we talked about, that could completely change how we do skin grafts for burn victims or people with prosthetics.
Now this is all incredibly exciting, right? It's a huge leap forward. But let's pump the brakes just a little. We're not quite living in a sci-fi movie with biohybrid androids walking around. Not yet anyway. There are still some pretty major challenges to figure out.
For starters, this living skin needs to be fed. It needs a constant supply of nutrients to survive, which means scientists have to build some kind of artificial circulatory system for anything bigger than a small patch. Then there's the next level of complexity. How do you add things like nerves so it can feel, or hair follicles, or fat layers? That's a whole other mountain to climb. And of course, the big one, making this affordable and scalable. Right now, it's super complex and expensive.
And all of this brings us to the final and maybe the most fascinating question of all. A question this technology kind of forces us to confront. As we keep blurring that line between living thing and machine, you have to ask yourself, if a robot can feel, if it can heal, if it can smile with living skin, at what point is it still just a machine? This smiling robot isn't just a cool piece of tech. It's the beginning of a whole new conversation about what it even means to be alive.